Welcome to this video about installing the Delft3D Flexible Mesh Suite using Visual Studio 2019 and the Intel oneAPI. The nice thing about the Intel oneAPI is that the Intel FORTRAN compiler I thought is now free, whereas it used to be paid for, so that's great that there's another free compiler on the market. So this is a follow-up to a previous video. I put the link down below where I ran through the compilation of Delft3D Flexible Mesh with Visual Studio 2019 and Intel Parallel Studio. And yeah, there are a number of things in that video that people asked for. One of these was Intel oneAPI, which I've just got around to installing myself. And also, yeah, people were interested in some of the other parts of the process, like downloading the source code. So in this video, we're going to do everything with some time acceleration to make the video not too long. But yeah, we're going to download everything and we're going to install everything. And I've also added some additional files to the gist I set up for the last video. That is a README, so we can see here is some directions for what we're going to do in the video, and I'll update this if anything is wrong. And then yeah, there's a few other scripts in here. One for actually helping get the Delft3D code. One for a bit of post-processing. I've also added some other post-processing software, which we can see in a bit. And then yeah, the updated prepare SLN auto file, which is for producing the Visual Studio solution files. Note that this will only work with oneAPI. It won't work with Intel Parallel Studio now. It's been changed to work with oneAPI, but it should work with different versions of Visual Studio should you have any version prior to 2019. So I would say the first thing to do is to download these files. So yeah, there'll be a link to this gist in the video description, and yeah, you can just click download zip, and yeah, that'll give your files here. And yeah, let's move them to somewhere simple like documents or something. So we just cut this out and stick it in documents. There we go. So let's make a folder in here because then it'd be easier to copy and paste the address. So let's call it D3D compilation. Let's move these. Yeah, and then when we click this up here, you got the path which we can copy into terminal. Yeah, so for this, I'm going to use PowerShell, which is the new command window. Most of the commands are in PowerShell, so you're going to want to be able to start PowerShell in an admin mode. So yeah, just to demonstrate, if you type PowerShell in the search bar on Windows 10, it'll appear, and yeah, you got a few run as administrator. That's what you want to do here, just to make sure you have access to everything, and this blue window will appear. And the first thing I would do is, yeah, just move to this directory here so you have access to these files. CD. Whoops. Oh, needs to be in quotes because of the space. There we go. Okay, so we're ready to go. Right, so it's about, the only things I've installed on this computer are Chrome and for access to passwords and a clock. So it's about 20 past 10, just past 20 past 12, 12, Irish summertime. So we'll keep it on this clock. I'll try and keep it visible so you can see how long it's taking. I have about a 10 megabit per second download speed. So yeah, you'll see particularly downloading Delft3D itself can take a long time, so you'll get an idea of how long that takes. Right, so let's start the process. So I'm just going to follow through this this README here on the gist, and yeah, I'm just going to follow it here. I'm not going to open it locally just for now. So yeah, beforehand, in the previous video or in the comments previous video, I recommended using Tortoise SVN to download the source code, but I think perhaps that's overkill for a lot of people who don't necessarily want to use the subversion repository or post code backup. They just want to download it. So what I've done is I've created a script that should do everything for you, but yeah, you need a command line SVN client to do it, and we're going to download Slick SVN to start the process. So you can just follow the link here. I'm using 64-bit Windows. I'm going to download and install it. It's in a zip for some reason. And yeah, it might complain. I wouldn't worry about it because it's pretty legit. So typical is fine. And then in our PowerShell window, we should have access to SVN now. We might have to restart the window. So sorry about that. I'm just going to copy this command here. So let's close this down and open another one. Okay. Let's thinking about it. I'm doing this all in a clean virtual machine, by the way. This is a Windows 10 virtual machine that I installed. And that is, oh, there we go. Okay, we'll just paste that command back in. Oh, copied the wrong one, add the quotes. Okay, there we go. Okay, so back to our instructions. Let's go back. Okay, yeah. So I've downloaded this code, but the first thing you really need to do is to make sure you have a username and password for the SVN repository, the Deltaris SVN repository. So if you follow this link to the Delft3D website, it gives instructions about how to get a username and password. So yeah, it says please click on sign in, but it means log in, and then you can go to register. And then, yeah, you need to create a My Deltaris account with an email address and a password, and they will then send you a username. Now, note the username is usually just the first part of your email, but one mistake you can make is to use your email address when using the SVN server. Password tends to be the same, so you have to wait until they register you. So it's important to do this first and not go for you. Nothing will work unless you've got a username and password. So I'm just going to assume that you've gone through this step and you have the username and password available to you. After registering, install Slick SVN and grab the get Delft3D tag.ps1 file. So this is this PowerShell script that I wrote, and essentially it's just calling an SVN command, but because it's so big, often it can break when it's doing the checkout, and so all it does is it basically keeps asking until the job is done. We need to choose a path to where we're going to download it to. I'm just going to use the path I'm on, and I'm going to add this Delft3D-68819. 68819 is the recommended tag for Delft3D FM. Just going to see. So if you go to the source code page here, then yeah, for Delft3D dflow FM, it recommends 68819, and so that's the tag I'm gonna check out. So essentially, all you have to do, given we've moved to the directory where this file is, we just have to type this command. and replace your username with the username you've been given. It will prompt you for a password. So, and replace path to Delft3D-68819 with wherever you want to put the code. So just going to copy this. Okay, and type my username. You may or may not be able to see that. So yeah, the code asks, I don't think this export should be in here actually. I have to change that. Confused me for a bit. The code asks for a tag, your username, and then the path you want it. I don't know what that export is doing there. I'm going to change it right now. So here's the README. I'm going to take this export out because I really don't think that's right. I think that's from the previous version. I'm going to save the changes. There we go. Okay, so yeah, this is the command tag, username, path, and I'm just going to change the path to relative to this this folder. Okay, yeah, so I don't have permission to run scripts because this is the first time I've opened PowerShell on this machine, on this virtual machine. So there's a command I've put into the README that will give you permission to run PowerShell scripts. So I'm just going to copy and paste that into here. And yes. Okay, so that's given me as the user permission to run PowerShell scripts, basically. Don't run any scripts you don't trust. So if I run this again, it's do not run, got upset. Okay, I'm gonna run it once. Okay, so I have to enter my password, so I have this stored up here. Okay, back to my PowerShell window. Ooh, don't know if that worked. Okay. I right-clicked there to paste the password. Control V didn't seem to work. Okay, and now it started downloading. So yeah, if the script is written properly, this will just keep trying until the Delft3D source code, that tag, is downloaded. So yeah, I'm going to turn off the mic and go and do something else because this can take a while on my internet connection. So yeah, I will be back when it's done. Okay, so we're done. So yeah, it took about an hour. I'm not sure, to be honest, if you had a faster internet connection, it would make any difference because I suspect that a lot of it's down to the files being served from the Deltares server. But there you go. So you should have, let's see, let's find our folder. Where are we in documents? So there you go. There is an SVN copy of the Delft3D source code for tag 68819. Right, well, it is lunchtime here, so I'm going to pause the video to have a little bit of lunch, and then I am going to come back and we'll continue with this process. Back in a sec. Okay, so lunch is over and feel refreshed and ready to get on. So, like I said, at this stage we've got an SVN repository of a checkout of this tag. But as you'll see in the guide, my recommendation is not to do the compilation in that SVN repository. It's to I would make a copy or an export, in this case, of the code to a different file path and work on that. The reason for that is that if something goes wrong in the compilation, it's much easier to work on a clean copy than it is to try and recover it. So generally, you would delete the source code that you have and start again, and you don't want to go through that process of downloading the whole code again. So we can just add this command here, svn export, the path to your tag and your SVN repository, and then the path to where you want to put it. So just do a quick ls, and then you can see that this is where our tag is, where our repository is. So I'm just going to do something really simple, svn export. Yep, that one, and then I'm just going to put the code I'm going to work on into a folder called Delft3D, and it's going to copy all those files over to the Delft3D directory. While that's going on, we'll have a look at the next step. So we're going to use that this path to Delft3D, the export that I'm just doing now. We're going to use that for the rest of the guide. Okay, so now we're going to install the rest of the supporting software that we need. This includes Python. We need a Python to use the Visual Studio solution preparation script. We obviously need Visual Studio. And we're going to need the Intel oneAPI too. And we're going to need two parts of that. We need the base toolkit and the HPC toolkit, because the HPC toolkit is actually what has the Intel compiler. So yeah, it just says follow the default installation instructions for Anaconda Python. So let's start doing that. I'll just check how my checkouts go in. My export, still copying files. So we'll just move on. I will wait for this to finish so I can put a clean time marker on here so it doesn't get confusing. Okay, so even just making a copy of the code takes a little while. You could potentially do some of this in parallel, obviously, this process, but I just want to do it step by step, so there are clear divisions between the different stages. So let's have a quick look then, and we should have our copy here in Delft3D. There it is. And yeah, between these two folders, I suspect they're quite large. So yeah, about 4 megabytes of data, and I suspect that the checkout is bigger. Yeah, so 2.5. So 2.5 to 1.5, and that's to do with the history of these files that are in the SVN repository. So okay, so that's done. Let's move on to the next step. So the next step is we're going to install Python, Visual Studio, and the Intel FORTRAN compiler. You need Python to prepare or to run the Visual Studio solution preparation scripts, which get the Visual Studio solution files set up for using your version of Visual Studio and the Intel FORTRAN compiler with oneAPI in this case. So yeah, we're going to use Anaconda Python, which is a good Python distribution, cross-platform, is good for Windows. Obviously, we're going to need Visual Studio,
And we're going to need two downloads for oneAPI. We need the base toolkit and then the HPC toolkit, which actually contains the FORTRAN compiler. So, okay, let's get going here then. Okay, so it's auto detected. Python 3.8 is fine. It'll work with Python 2 and Python 3. The installation scripts, that is. So yeah, started download. It's going to take 8 or 9 minutes or so. So be back in a sec. Okay, so Anaconda is downloaded, so let's install it. Just double click. Yeah, I mean, you got an option here for installing for all users or just for yourself. Unless you happen to be using multiple accounts on the computer and you want to have access to the Anaconda Python across all of those accounts, I would just stick with just me. If you do want to use it on all accounts, then you can put all users in as the option here, but you will need admin privileges to do that. Yeah, and I would just follow the defaults here. Yeah, you can. I wouldn't worry about putting Anaconda free on the path, and you can choose to register Anaconda free or default Python or not. I don't see why not. So let's just click install. Okay, so it took a little bit of time to get Anaconda installed. Could be because it's a virtual machine, but anyway, it's done now. So I don't need to see any of this. Finish. Okay, so we can just check it's done. We have an Anaconda free directory, and we're going to use the Anaconda PowerShell prompt from now on. So click here. Okay, so just as a point of reference, because we'll need to know this later, Anaconda and the package manager, which it uses called Conda, relies on the concept of environments. So an environment is basically an isolated Python interpreter and packages that you install into it, and you basically can have a lot of these, and they don't interact with other environments. And the default environment it creates is base, and the idea is that you don't do anything into base. And you would, if you wanted to add packages, you would do it in a new environment. We can run the solution preparation script in the base environment here. So you don't have to do anything, but for some of the other post-processing stuff I'm going to show you today, we will create an environment. So let's just check Python is working. We can literally do just Python-v. Ooh. That isn't what I meant to do. I tried to get the version, but I did the wrong command. Let's try it again. Maybe big V. There you go, 3.8.8. Okay, great. So that's step one. Let's close this down. Okay, Visual Studio. So for Visual Studio, choose the desktop development C++ workload. Okay, so we need to download it first. We'll use the community edition. It's fine for this process. Visual Studio wants to download multiple files. Okay. Okay, we open it up. Okay. And yeah, this is an installer that's going to download on the fly, depending on the components that we need. Okay, so let's just see if we can make this a little bit smaller without closing it. Yeah, okay. Can I drag this across? Working on a small screen. Okay, there we go. So what we want to do, if we look at our instructions again, go back to the guide. Okay, so for Visual Studio, we need to choose the desktop development with C++ workload. So let's find that. You scroll down. Desktop development with C++. So we tick this box. And then a bunch of options are going to appear. And we need to select a couple of the extra options here. So let's have a quick... Let's go back to the instructions. So we want C++ MFC and C++/CLI support. So... And yeah, these are part of the list that you find on the Delft3D source code instructions. So essentially all of the rest of this is already pre-selected, and you just need to add these couple of extra things. So let's find those in the installer. So MFC, CLI support. Hi, this is me from the future. I realized I made a mistake here where at the installing Visual Studio installation stage, I missed one of the modules. The C++ modules for V142, you have to select this as well. So when you're on the installer page, make sure you have C++ MFC, C++/CLI support, and C++ modules all selected. Otherwise, the compilation's not going to work. I updated the README here to include all three. So with these three, you should be good to go. And that's it. And we just click install. Just check I haven't missed something. Yeah. All good. So click install. 10 gigabytes required. So yeah, this is going to be a bit of a long process again. Just check that it starts. Okay, there it goes. So yeah, this is going to take a little while to download. I will again turn the mic off and we'll accelerate time, and I will speak to you again once this is installed. Okay, Visual Studio is installed. We won't sign in for now. Doc theme. You may have to sign in. I'm not sure. Sometimes it gets a bit upset unless you do sign in. There's usually a trial period. It's free, but they like you to have an account because it's Microsoft. So yeah, we'll just see it start up. We're not going to do anything right now because we still need to install the FORTRAN compiler. It's important that you do Visual Studio first, though, because the Intel installers will look for Visual Studio in order to be able to integrate the FORTRAN compiler into it. So yeah, there we go. We'll just close it down. Okay, now let's find the next step on our guide. Okay. Yes, so there's actually a good guide, another guide already existing for installing the FORTRAN compiler using oneAPI. So if we could, you can follow the link there. So refer to the oneAPI install guide to download a oneAPI FORTRAN compiler. So we want the Windows one. So install with a GUI, I guess. Intel never makes it super easy to do these things. Okay, that's not helpful at all. Yeah, I know how to install. Prerequisites. Like, I guess I need the software. Oh, good gravy. Okay, so back to my guide. I have some direct links to get the installers. So just click on the base toolkit first and download the toolkit. Whoop. There we go, get it now. Okay. Try again. Select your operating system. Blimey. Windows. Recommended. Installer type. Online. Okay. Online installer. Download. Get your download. Continue as guest. No. So yeah, takes a while. So yeah, let's just wait for it to download. Actually, that guide is quite useful in determining which components of this setup you need. So let's go back and find that Cyvision guide again. So you're going to need the math kernel library and optionally the debugger. So let's put those in. Let's do this. Open it up. Yes, please. Yeah, there are a lot of things you can install in oneAPI. So yeah, it's good to have a little guide as to what's required, a minimal installation for doing FORTRAN. Okay, so this is the second attempt at installing oneAPI, the base toolkit. The first attempt failed, so try again. Okay. I lost my internet connection and it didn't like it. Okay, here we go. Yeah, it doesn't fit very well onto the screen here. We're going to customize the installation because we don't want everything. It's annoying there's no like way to untick everything, but we just keep unticking here because we only want the math kernel library. Keep unticking. And the GDB. So let's click forward here. Yep, we want to integrate with Visual Studio. I don't want my data collected, thanks. And off it goes. So hopefully this will work better this time. Okay, yeah, that was a long process, but it's finished. The GUI went a bit mad there, and appeared to download 1.5 gigabytes of the gigabyte it was supposed to download. But there you go. Okay, we got it in, and it did it. So sadly, we've got another part to go. So yeah, let's close this down. Yeah, and let's get the other one. So yeah, let's get back here. And the HPC toolkit. Just duplicate this one so I can have a look at that. Guide again at the same time. So okay, download the toolkit once this web page loads properly. There we go. Okay. Okay, here we go. Windows. Installer online. Download. Okay. So yeah, we're going to install MPI, C++, and FORTRAN. Once this gets going. Okay, here we go. Okay, and then we're going to pick customize again. So let's see, C++ compiler classic, FORTRAN compiler classic. I'm not going to worry about that. We're not going to worry about that. So yeah, this is another big install. Although only 6.5 gigabytes, it's only 600 megabytes to download, but I kind of, yeah, these numbers don't add up, so maybe it won't be that. Anyway, let's give it a try. Yeah, we want to integrate again to Visual Studio. I don't want a collection of my information, and here we go, install. So yeah, not super sure exactly how long this is going to take. The GUI doesn't seem to work entirely properly. So yeah, it says 606. So yeah, hopefully it won't be as long as the last one, but we will see. I'm going to switch the mic off again, and I will be back when it has finished. Okay, so we've got the FORTRAN compiler now installed. Certainly, the integration with Visual Studio takes an awful long time. I hope they improve that in the future as oneAPI matures. So let's see. We've got HPC base. That's what we need. So we can close this. Yes, thank you. And now let's go back to our guide. Okay, so everything we need is now installed. It's 5:10 here in Ireland, so I think I'm probably going to stop for the day and come back at this tomorrow. And we'll go through the solution file preparation for Visual Studio and compilation and testing. So see you in a bit. Hi, so it's now the following Wednesday, around about midday. Clearly didn't continue this tomorrow morning, but hopefully we'll get it finished in the next hour or so, clock time. Let's have a quick recap. We've downloaded the Delft3D source code, and we have the repository the repository at tag 68819 here, and then we have an exported copy of the version that we're going to work on here in this Delft3D folder. We have all of the required software to prepare the Visual Studio solution files and then compile installed, so Anaconda Python, Visual Studio, and Intel oneAPI for the FORTRAN compiler. And now we're going to take the next step and prepare the Visual Studio solution. So first you need to copy prepare sln auto.py, the one of the files that's in this gist, into the Delft3D source directory. And I think I haven't done that yet, so let's just copy and paste from here into Delft3D source. Here we go. And then this complements basically the script that's included in the source code to work with Intel oneAPI. Now this will work with any version of Visual Studio currently. It'll only work with Intel oneAPI though. This won't work for Intel Parallel Studio now. The other thing, same caveats from the last video in that PETC is disabled. So I haven't tried whether seeing if this compiles with PETC or not, but for compilation here, I've disabled PETC. So, okay, what do we need to do? So I've copied that. Now run the script from an Anaconda free PowerShell prompt. Okay, so if we go to the start menu and look for Anaconda free, we'll see a PowerShell prompt. Anaconda, there we go. Okay, so we don't have to do anything with this. It just says opened the base Python environment for Conda, and that's sufficient to get this script to work. So we just need to move to this directory. So I'll just copy and paste cd. I need to put it in inverted commas just to make sure that space is recognized. And then it's really simple. We'll just do Python and the script name. Hopefully this will work. Okay, there we go. So yeah, that should have generated the files. So it's detected my Visual Studio version as 2019. It's got .NET already installed, something in Windows 10, I think. So 4.6.1, and the Intel oneAPI version is 2021. Solution path is blank, just means the solution files have been created in the current directory. So there we go. So if that's worked properly, we should be able to open Visual Studio and open this solution file dflow_fm_open.sln. So let's have a go. Let's open Visual Studio. I might have an old version here. I've tried to do this before. Okay, so let's just click open a project or solution. And then let's find the file, src. There we go, dflowfm_open, and open it. Okay, just see if things look all right. Yeah, it's FORTRAN and there's C components. They all seem to be have their little icons, which seems to show they work. There's no extra steps you have to take here. Actually, it just works out of the box for this one. Beforehand, yeah, we had to change something in one of the netcdf input files, but you don't have to do that here. The only things you have to do are switch the solution configuration to release and switch the platform over to x64. There we go. And I think that's in the instructions here. Change configuration from debug to release, change the platform from Win32 to x64. Then the last is select build solution from the build menu. So let's go build solution. Yeah, and then this should take a little while. I don't know if it's just because of my screen resolution, but I don't have the errors here. I'm just going to see if I can see if I can get that. Okay, so no errors. Lots of warnings. That's to be expected. It's talking about some missing NuGet packages. I don't know if that's going to be an issue. I'm tempted to say no, but we'll see. It's going to kick lots of warnings, and we'll see what happens. I will again mute the mic while this is going on. Yeah, just because it can take a little while. So I'll be back in a second. Okay, so the build completed. I think it's a little bit slower than it would be not on a virtual machine. Clearly there's a bit of a disadvantage by doing this build on a virtual machine, but there you go, it's done. There are no errors, lots of warnings. That's pretty typical. I believe because there's no errors, this should work. Yeah, the big difference between oneAPI and ParallelXE with the Intel compiler is particularly that the MKL DLLs have changed their names. They've added a .1 in front of the .dll, so that's one of the things I had to change in the solution file, was to copy these files. It's something to note if you're trying to patch this into, say, an older version, is that the DLL names have changed, so you might find that it wouldn't link if you don't copy everything. So something to note. Right, so the next job, now we've got it, is to test it. And yeah, I have a look at our README here. And okay, so I create a little test case because perhaps not everyone has a test case for this. So yeah, a little example of a flume. That's in a GitHub repository. So we'll just click here. And hang on a sec, I'll tell you what, we'll right click so we can have both. Download some path for it here as dflow.fm flow. So let's just go to there and we'll get the code in a zip. And let's look at it. Okay, and we'll just cut this out of here and put it next to all of our other code. So we'll just pop it here. I'll just rename it, take the master off. Oop. Okay, there we go. So yeah, this is the test case. Okay, so we've got that, and let's go back to our instructions. Okay, from PowerShell prompt, we want to go to the input folder in here. So let's just use this PowerShell we had before. So cd. So let's just move. So cd // /dflow fm flume flow fm input. Okay. Okay, now we need to find the path to where our run dflow.fm.bat script is. So let's do and then we're going to go see if we can do it with // another one maybe. Delft3D, yeah, okay. Source bin x86 dflow fm scripts run dflow.fm.bat, and then we're just gonna point it at the flowfm.mdu file here. So okay, and press enter and it should run. Fingers crossed. Oh, sure, man. Okay, so it worked. So there you go. So the most basic simulation of some water flowing through a flume, and we've generated some outputs. So let's see if we can see that. There we go. So there's some output files. So the compilation worked. The code is working. Next week we do some post processing. I create a little Python script that's in the same again the same gist. This plot underscore map underscore u, and that uses another tool that's produced by Deltares, open source Python tool called DFM underscore tools, and that's available on GitHub in this OpenEarth organization. And we're going to create a Conda environment to run it because it needs a few packages that aren't in the base environment. So here's some instructions for creating a Conda environment. And this just creates basically an isolated set of Python packages that you can create and delete at your convenience, and it won't interfere with any other Python installation you have basically on the base environment. So let's just copy and paste these over into our Anaconda PowerShell prompt. And this is going to download packages from the Anaconda main repositories. Okay, so that's finished. Didn't take too long. We now have a Conda environment called underscore Delft3D. Excuse me. Called underscore Delft3D, and yeah, we can just use this command here. I'm going to Control-C to copy it, and then right-click to paste it to activate that environment. There we go, and then all of these packages are now available in this environment. So particularly Python, obviously, matplotlib, netcdf4, numpy, pandas, and scipy, which are the dependencies, this DFM tool. So now we're going to install that program. We're going to install this directly from the GitHub using pip. So we're going to copy this command here to install DFM_tools. So making sure that our Delft3D environment is active. And this is going to get the code. Ooh. Don't have Git. Okay, well, I'll add this into the list. Edit. Where are we? Here we go. Ooh. Okay. Put this in here. Git. You won't need to do this step that I'm going to do now, but I'm just going to make sure that, because you presumably will have copied and pasted what I put into the thing here, to the README. Okay, Git. So right, yeah. Let me just fix that. So conda install Git. Yes. So yeah, you shouldn't have to go through this step. That's just I made a mistake and forgot to put that in the list of things to install. So I'm just pressing up. I'm going to call this command to install DFM_tools again, and it should work this time. Okay, there we go. So everything is installed now. You can do conda list, for instance, to see what's been installed. It should show you everything in the in this environment. And yeah, there's DFM-tools there. It says it's come from PyPy. I've actually installed it from Git, but yeah, it just it's just what it falls back to at this point because we used pip. Okay, so it's ready. We can now use the script. So yeah, we're going to copy this this Py file, which we already downloaded, and we're going to move it into the output directory of our results. So this file here, I'm just going to Control-C and Control-V into there, and then I'm going to move my terminal. So /output. There we go. Here's our files. And then I can just run this command. So working on the map file, Control-C, right click. And there you go. So yeah, that is the flow at the end of the run and at 1 meter per second. So maybe 0.8 meters per second, actually, I think it's set to. So yeah, just to show that it did something. And there you go. And yeah, that is the end. I think there's nothing left in the README. So what time is it? The clock's gone. That's unexpected. So yeah, it's about 5 to 1. So it's taken about 55 minutes to go from having all of our dependencies installed and the source code to actually preparing the solution files, compiling and testing. So yeah, I can't remember quite how long it was before. Maybe, what was it? 6 hours maybe that it took on Thursday. So yeah, it's about a 7-hour process. Should be a bit quicker on without a virtual machine. But there you go. That's the whole job. So yeah, thanks to everyone who's watched the video all the way to the end, and thanks for all your likes and subscribes. They're much appreciated. And yeah, I'm sure we'll be producing some more content in the future.
Hope you enjoyed the video.